Hey guys, CEO here. What is sound?
Sound is waves that our ears and brains perceive as sound. So, what are the different parts of a sound wave? Over here, we have the crest and the shroud, the high and low parts of a sound wave. And over here, we have the amplitude, which is how far the median is from one of the peaks, which decides how loud the sound wave is. And the wavelength, which decides the frequency or pitch of the sound wave.
Here, you see a tone generator. As we just talked about, the frequency or pitch of a sound wave is determined by the distance between each wave, also known as a wavelength. Hertz represents the frequency of a sound. The higher the number, the more frequent the waves are being played, resulting in a higher pitch. The lower we go, the waves become less frequent, causing it to become a lower pitch. This is why subwoofers, a speaker specifically made for playing low frequency, looks like this when it's playing sound. Now, it's time to design an amplifier. Why, you might ask? Well,
Oh no, the phone too quiet. I cannot hear this epic rap by XX Asian Boy XX. I know someone that can help me. Yes, I need phone loud.
Speakers.
No, me poor.
Yes.
Yes.
our brain perceives sound when our ears transfer sound waves into an eardrum, which turns the waves into a mechanical energy. This mechanical energy sends fluids across the cochlea into hairs on the nerves that send sound, sending signals to the brain about the sound. As most of you already know, we have access to 3D printing technology, which allows us to 3D model our amplifier, then print it out. But is plastic really a good material to make an amplifier out of?
First, we had to decide on a material, which ended up being plastic for two reasons. It is very easy to model into specific shapes using a 3D printer and software, and it is very functional in reflecting sound towards an audience. When sound hits a material, it either absorbs, reflects, or transmits through the object. Since plastic has a high ratio of reflection, it is a viable material to use. We hypothesized that a horn shape would do the best, which uses acoustic impedance to amplify sound. This works because the curvature of the horn creates a large interface for the sound to interact with the air. Additionally, the horn directs the sound in one direction.
Now, let's go over some amplifier designs. In this design, we abandoned the horn shape entirely and decided to use a still curvy, triangular design that looks like this. It also did rather well as it utilized the principles of acoustic impedance rather well. It was able to amplify 12 decibels from 81 to 93 at 261.63 Hz.
In this design, we used the aforementioned horn shape found on instruments like a clarinet and French horn to create a larger interface through a curve similar to an exponential or hyperbolic graph. This design resulted in the total amplification of 16 decibels from 69 to 85 at a wavelength of 261.63 Hz, which is rather decent for an amplifier.
In this design, we simply put a phone in the cup. This design is rumored to be a simple, poor man's amplifier, which uses a similar concept to the horn to match the acoustic impedance. Like all forms of engineering, we had to go through several iterations to get it right. I tried many different body shapes, and I found this one to be the best. Now that I showed you all the designs, here's a real-life demonstration of the amplifier. First, I will show you what it is like without an amplifier. Let's try that one more time, but with the amplifier this time. First, I will do one without the amplifier as control, and another one with the amplifier. If you have sensitive ears, I advise you to block your ears now. In conclusion, you can amplify sounds effectively without more digital input. I hope you learned something new, and thanks for watching.